All right, Python students, let's learn how to manage exceptions in our code to prevent it from crashing so often. I'm going to show you some different types of exception handles, starting with the most generic one. But first, why do we need exception handling in the first place? Well, our first value error is something that we'll develop in a sec to kind of see this in more specific detail. But let's imagine a scenario where you want to gather a number from the user. And so you ask them for an input, actually, that says enter a number. And maybe at this point in your projects, you've hit this problem where you get them to enter a number, and then you want to say, like, print you entered, and then you actually add on a value. So we're going to format this string to tell them the number that they entered. Okay, so let's run this and enter a number. Let's say I entered 23. You entered 23. Wonderful. What's the problem? Well, what happens if I decide to be silly, or I typo and I just type in some letters? And in this case, it prints out this value as well, because it's a string. When I typed in the number initially, it was taken in as a string. So I'm actually not yet at my full solution for this number, because I need to do the casting into an int. Here's where the problem occurs. If I type in a number in this case, it's happy. But what if I try to cast, because I want this to actually be an integer type data, maybe I'm going to use it in a calculation later. I type in hello. I get a big error and my program crashes. And notice I didn't get this printout. It didn't occur because my program crashed before the printout came, because I can't cast a bunch of letters, a string, into an integer. It only works for actual number characters. And so here we go. We have a situation where if the user isn't careful and they accidentally typo, maybe it's something as simple as they're typing in some number and then they slip and type in a letter at the end by accident, the entire program crashes. That won't do. We need a way of making sure the program can't crash in the middle when all we're doing is something simple like asking for an input. And so here's where we have something called a try except statement kicking in. And here's the format for it. We write try, and then we write except. In the body of the try is the logic we're attempting, and an except is the result if something goes wrong. So we're going to try it except if an error occurs. So let me insert this content in my try, and then under my except, this is held for where, well, let's just type this in. This is where we end up if there is an error that will crash the program. So in here, I'm going to say you typed in something dumb. And let's see what happens. If I enter a number, 34, you entered 34, and the program continues to the end happily. But if I enter blah, some string, you typed in something dumb. Notice it finished without crashing. And in this case, we actually managed to continue on without a problem. Now, keep in mind one thing here, that when I typed it in properly, it says you entered 2. It runs this line of code. But what if I typed it in incorrectly? You typed in something dumb. It doesn't run this line of code. In the try except section of code, wherever the error occurs, that's the last piece of logic or functional code that runs in this block. It's going to skip everything else after it. So no matter how many times I print something, more text, I can copy and paste this. I could just loop this, but let's type this in a bunch of times just to see it's really clearly here. Oh, hit it twice. If I type in a number, I'm going to see more text appear those 4 times because it's 4 times here. It doesn't matter how much content is down below. If I have an error, you typed in something dumb. It doesn't allow any of the rest of this functionality to run. It skips over it. Okay, so what if I want the user to have to type in a number? What can I do? Well, I can actually do something clever here and put in a while loop. I can actually make a Boolean. Let's just say good input equals false to start, and I say while not good input. I'm going to run this loop. And inside of this while statement, I'm going to keep on trying to get some good input. Let's just close this down here. And so what I've done is I've said I don't have good input yet, and as long as I don't have good input, keep on trying to do this. So I need a way of breaking out of this loop, so otherwise it goes on infinitely. So what am I going to do is I'm going to say that after I get a good input, which is only going to run, this will only run if I get a good input. I'm going to set good input to be true, which should break me out of the loop. Let's see what happens here. If I enter a good number, you enter 2, good input is true, the loop ends, I move on with my program. However, if I type in something wrong, type in something dumb, I can keep on typing in dumb things infinitely until I finally give it what it wants, and then it breaks out. What I've managed to do here is guarantee that my program gets a number input by the user, because maybe the next part of my program down below relies on there being an actual number in this num variable. And if I don't get one, the program is just not going to work. I can enforce the user to actually make a choice by using this try except logic to make sure and enforce that I get this properly. Really useful when we're making menu systems and lots of other things in our programs as well. Okay, so something that to note here is that this is just a generic try except block. Any type of error will be caught by this, and this is probably the most common one that you'll use. But I want to show you that we're actually able to type in specific values in the except section to look for just certain types of errors that we might want to deal with in different ways. So in this case here, from a string to an int, we have this value error that, actually I'll just do it like this. We put in under the except to specify we're looking specifically for a value error. And now if I run this again, type in something dumb, everything runs just like before. The difference is really that in this case, my program's only looking for a value error type things. Other types of errors won't be caught in this, which there might be a circumstance where you care if that's the case or not, because you actually are able to do multiple except statements down below. So here's something, for example, that I could do. No, we'll come back to this afterwards. Let's look at our next example first. So we've covered the second type. The third type that we have is called a type error. Let me show you how this might work. We'll just come down and erase this and just look at our type error here. I'm going to create a list of data. Let's set our values of our data just be 1, 2, 3, 4. Good enough for now. I'm going to say for x in data, I want to print out the value of x just to see that it's all working here. I got my pieces of data. But what if instead I wanted to do something a little bit more, well, permanent? I wanted to say in range, in my length of my data, I actually want to look at the data's x entry. So far, it's the same. We've covered this algorithm before. What I'm doing here is I'm trying to set up my ability to actually change the data in this list. So here we go. I'm going to actually add 1 to every value, and now I'm going to print out my data at the end. And now I see that I've actually added 1 to all the values. 1, 2, 3, 4 became 2, 3, 4, 5. So far, so good. But remember, in Python, our lists and other data structures like this are able to accept in different types of information. So what if I was to have 5 stored as a string instead of an integer, and then run this code? Type error. I can only concatenate string, not int to string. So I have an issue with the type not really matching up. So what can I do here to still allow this to happen without that error happening? Well, I can have a try and try to do this loop. And I'm just going to say except type error, where I'm going to say maybe this entry wasn't or isn't is not a string, an int, so ignore it. And this is going to allow me to actually skip over anything that's the wrong type of data in this loop. So I've actually added 1 to all the integer values, but skipped over the string. Why? Because that particular loop broke out to the exception. And notice here, if I make this a string, the 3 inside of it, and run this again, it still works, except that this 3 didn't change because it skipped that piece of data because of the type error exception. So it's another strategy for avoiding mixed data types if I want to, because this particular logic only applies to some of the data and not others. And by writing this in the try except block, I've managed to avoid any of the issues that would crash my program. We probably want to use like a type check type of conditional logic to manage this to have the best type of code possible, but this is a solution to this problem that you might have come across, or will come across to deal with different type errors. Okay, let's look at another example. So there's our type errors. So yeah, we already had a few different examples here. Let's go to our zero division error. This one's pretty simple. What happens if I get a num, which is an input from the user, type in a number to divide into, I don't know, we'll say the number 5. And then I say the result equals 5 divided by our input. And I want to maybe print the results. If I run this code, number to divide into 5, what if I divide 5 into 5? I see that I have, well, I forgot again, cast it to int from our input. Maybe we want another exception. This is a good one to see our layered exceptions around here. So I'm going to cast this into the number 5, and the result is 5 divided by our input, and it says here unsupported operand types for int and built-in function or method. So oh, I'm num. Why am I dividing by input? That's my bad. I'm just mixing up the names because I'm rushing in my head here. Let's continue. 5 divided by 5 should be 1. Wonderful. 5 divided by 2 should be 2.5. 5 divided by 1 should be 5. And 5 divided by 0 should be a crashed program. Wonderful. Awesome. We're not allowed to divide by 0. So a zero division error exception can catch this. Let's try to do this, and otherwise, except if we have a zero division error. In this case, we want to print out do not divide by 0, silly. And so if I try to divide it by 0, my program doesn't crash, but I remind the user to not divide by 0 to avoid that from crashing the program. So it's kind of a more of a niche situation, but still a valuable one to be aware of. Okay, one more here. Let's keep on going. I think you're getting the idea. An index error is one where, let's say I have another set of data, and I just have, so here, just to keep it simple, 1, 2, 3, 4, 5, and then I say for x in range, and I kind of forget to look for the length of my data list. I just say in x of range 5, and then what I want to do is I want to print the value of x. And in this case, I'm just printing out the value. Actually, I want to print out, the data element of that number. That's right. So x in a range of 5, remember that the range is exclusive, so it doesn't include 5. It just goes from 0 to 4, which is going to hit all of these elements properly. But what if I am slightly too big? I've miscounted, and I try to run this. A list index out of range error, where I now have the issue of going out of range by accident. So I'm going to avoid this by, well, trying to run this loop around my data, and then I'm going to accept any index error, and just maybe tell the user something like, you went out of bounds again. How dare you? And I go through the first 5, and the last time I went out of bounds again. So now if I do it way too many times, it's going to, well, you went out of bounds again. Doesn't let me kind of continue in this loop because I'm out of bounds. So it limits the damage. I've processed the ones that I can, and it stops me from going too far out of bounds. Awesome. So there we go. There's a bunch of different exception types that we can kind of deal with and manage. And as I said before, you can mix and match different ones. So for example, what if I wanted to, let's keep this one here, in range 6, and then I also had this except, let's have maybe a, let's see, let me pull up another one. Which do I want to do here? Where's my list? I had a list here for us. Let's see if I can find it. There's a bunch of different types of errors that you can look at in Python that we're not really going to talk about or cover in this section. But what if we kind of go back to one I've covered here? I tried to just go down to a shorter list of ones that are maybe more relevant for us here. And let's go with a type error in this case here. A type error. And can I manage to kind of look for two of these things at the same time? Well, in this case, what if again I had this situation where I have a string mixed in with a bunch of integers, and instead of printing the data, I said I want to actually take my data and I want to actually add a value to it. In this case, when I run through this, I have the wrong type of data that I'm hitting first before I even reach this index error that breaks us out of this loop. So I don't even reach kind of this index error exception. But it's nice to have both of these things here, because what if I was in range and, sorry, what if I'm out of range, oops, but all the right types of data are there? Well, in that case, the out of bounds error is caught. So having both kind of allows me to anticipate both types of things, where the wrong data will get caught by the wrong type exception, the out of bounds will get caught by the out of bounds one. So I've kind of like provided a few layers of protection against this stuff. Now you might say, why not just use the basic exception? Well, the problem with that is that in this case, what if I just did this? Well, the issue is it tells me both messages for any given error. So how do I know what error happened? Well, in this case, because it says both messages, I don't actually know the type of error, meaning that for debugging purposes, figuring out what went wrong, this isn't that helpful. I know something went wrong, but which one of them? Well, the generic one is easier to write, but it gives me less information. This setup actually allows me to know specifically what went wrong with my algorithm. And in a simple example like this, it might be obvious, but as our code gets more complicated, you're going to be really happy to have really specific outputs of the things that are breaking and going wrong, so you can debug and troubleshoot your programs much more successfully. So there you go. Now you know how to manage exceptions of many different types, or just generically to keep your programs from crashing and to keep your logic flow a lot tighter and more consistent overall.